Hey, Bradley.
Hi.
Hey.
There he is.
I think Amanda has to go soon.
I know. Now I have to go,
Oh.
but I do want to say. So we had to meet earlier because I'm in Ann Arbor for a meeting.
Oh, okay.
And a few times I've been here, I see this, and I think I need to share this with this group. There is a dispensary, a pot shop called Information Entropy.
Oh, yeah.
Which is very funny. So, on that note, I have to go.
All right.
Thanks for meeting earlier for me.
All right.
I'll talk to you soon.
Talk to you soon.
Take care, Amanda.
Take care.
Okay. I don't know if you have to go, Morgan, but I can stick around and talk a bit more, like kind of go over some things here. I'm sure Bradley has opinions about this paper.
Well, I don't. Go ahead.
Well, I was just to your earlier points, Jesse, about Yogi's. Forgive me if I'm getting that name right, but is it Johan?
Yogi himself, like this is Yogi. He goes by Yogi, but his name is Hough. Yeah.
Okay. Just the discussion at the Active Inference Institute today was I think interesting because I haven't seen him. I like the host in terms of the questions that they asked and the kind of the probing of Levin and his student in terms of teleology and as well as basically Levin's difficulty in describing the complaints that you're talking about Yogi had with the Levin's redefinition. But I thought he restated that need for redefinition by his difficulty in understanding regeneration, as well as just I dropped some links in terms of Dennis Noble, Richard Dawkins debate again, and talking about. I mean, it's basically the two of them continuing their debate about the kind of determinism of DNA, right? And Dennis Noble just giving multiple examples of where this really doesn't work, at least in a kind of strict orthodox kind of definitions or understanding.
Is this by chance the one you're referencing? It looks like it's from today.
Yes. Yes.
Okay.
In terms of the Levin, yes.
Yeah.
There's also from today is a new Dennis Noble, Richard Dawkins, right? So which again, which is like it's not the same as Levin, but again, I see in their debate some of the same issues coming up in terms of Dawkins to some degree is the orthodox view in biology, and Dennis Noble to some degree is the person collecting all the kind of edge cases where that doesn't work, or that understanding is suggesting a need to think about things at a different ways, or to redefine terms in Levin kinds of ways. And yeah.
No, that's like that the language you just used is very meaningful to me, because I feel like that's sort of what I'm like. That's one way to talk about what I'm trying to do with like the embodied intelligence. What I'm going to talk about there.
Yes.
And a lot of things I'm interested in general. So
absolutely, and I think it's helpful, or again, kind of like the greater cybernetic reading group context, I think it's really interesting to see these kind of same problems come up, or these same debates come up in different fields, because again, you would expect that in the kind of greater cybernetics understanding of things,
It's
and
yeah,
yeah. So I mean, Levin uses like the one paper that we talked about in terms of animals undergoing metamorphosis, and then two, which we haven't discussed, but kind of some of the issues about regeneration.
mm-hmm.
That when he's talking about regeneration, I'd love to spend more time on that, like just how regeneration played into the discussion that they were that he was having with the active inference host, who was definitely like trying to what wasn't coming at it from a biological standpoint.
Mm-hmm.
But I think you can understand in terms of, or you see in the context of Dennis Noble's criticisms of Dawkins in terms of like, there's not necessarily plans for structure in DNA, and these this redescription being necessary to understand morphogenesis.
Yeah. Okay. That's yeah. What was I gonna say? I was gonna say something that I forgot, but nothing profound. So, hi Bradley. We didn't get very far. We just had some. We kind of spent. I had a feeling you weren't gonna didn't see or remember the update or whatever.
Yeah.
So I kind of just stalled for like 20-25 minutes, and then we talked a little bit about the paper. So we didn't really do that much. But we can basically recap what we wanted so far, and then
Yeah, that'd be
if
good.
you want to talk more about it or whatever.
Yeah.
And I know if you want to stick around and working, you're certainly welcome to. But basically, the paper this was from one that Amanda picked out. Yogi is the guy from they kind of got into the disagree strongly with Levin and that tweet bit, and also was the guy from this podcast that I mentioned. I really liked the podcast and they talked about things. And I want to kind of extract some things from that. But Amanda put together this really nice. Amanda did all these like screenshots from the stuff beforehand. We didn't really get to most of them.
Oh wow!
She took all these screenshots in
Great.
here, and we just had a couple notes here.
Why don't we go through that too? I think that would be nice to see.
Everything. Yeah. Basically, what we've done so far, I went to the abstract. The abstract is basically laying out this argument. It's basically saying.
What is the title of the paper, first of all?
Yeah, and it's very much. He puts Levin in the camp of people who are like way too computationally obsessed. Levin is a to cut to the second part where they really get into their polemic disputes. I spent a long time trying to figure out these different camps because what was it exactly they were getting at? But basically, he groups into Agential Emergentism and Computationalism. And he puts Levin in, and I guess apparently Rosen and Kaufman and these folks, or no, sorry, that's not true. Levin and interestingly, I think Montrona and Varela, and even Edson Thompson in this computational group or pan computationalist attitudes. in his mind. And it's interesting because a really nice point that Amanda made at the start of this was, where did it go? Like, why did Yogi react so hard to Levin's paper when I mentioned the living things paper? And we can kind of see here it's because he's building this view that the Levin is labeled as labeled, and it highlighted even particularly as for a particularly strong and explicit example of this attitude that he's against here. And that paper is this paper on having no head cognition systems for biological systems.
Right.
Let's see here.
Where cognition is everywhere. Correct.
Was that?
Where cognition is everywhere.
Yeah.
Okay.
And he Yogi, they're the same thing. So he's saying, oh, you see agency and what's they call it here? Agency and cognition are the same thing. And he's in the interesting point that Amanda made was learning more a bit about Yogi's perspectives, or like why was he so like polemic about it in that sense. But because in a sense saying that Levin's living things paper was almost a more diplomatic approach of a softer or a weaker argument, saying, well, let's maybe consider redefining these things. And that's kind of what Morgan just talked a bit more about. Oh, in the, I guess, active inference discussion, he's like, oh, well, here's why I want to redefine this way or whatever, and other things. But comparatively, Yogi's making a very, very hard stance, saying these are very different, and all these people feel it this way, and here we basically just got to this part of the paper where he really goes into his argument, saying, this is highly problematic, and one issue is that it's not discrete, and so on and so forth. But that's sort of the TLDR version. We basically just read the abstract, which is laying out his arguments. In this paper, we show that the process of relevance realization is beyond formalization. So there's something that's irreducible to symbols and formalization. He's drawing very strong boundaries between sort of the unpredictable nature of life, of the real world, and how living organisms have to experience it, versus sort of the artificial environments that computation exists in, or code exists in.
So what is Agential Emergentism? What is that defined as?
I don't know if we're at that yet.
Well, this first paragraph might be useful. So what are we saying here? All organisms are limited beings that live in a world overflowing with potential meaning. That's from Varela, Thompson, Weber. A world profoundly exceeding their grasp. Environmental cues likely to be important in a given situation and to be scarce, ambiguous, and fragmentary, which is, of course, that's just the way that the environment is, so the cues are not evenly distributed. Clear and obvious signals are rare. Very few problems we encounter in such a large world are well defined. On top of all this, organisms constantly encounter situations they've never come across before. So that's, like, I guess, speaking against maybe like this computational view that suggests that there's a clearly defined information processing model for everything. Although, this could be true of. This could be true. We could live in a very rich environment. So, this is. But I guess the idea is that you have that something has to emerge in the absence of cues, but also in the absence, or just to be able to fill the gaps of what you've not encountered.
Mm.
And so, it's like kind of like in a lot of machine learning models, for example, we train them on sort of a mean value or like a mean worldview. I mean, they can understand things they've seen before, but when they haven't seen things, that's when they run into problems. And what he's saying is that that's the normal state of affairs for like an organism behaving in the world.
Yeah, and he kind of sets up his, the fundamentally different, the algorithmic view and the, I don't know, the problem of relevance and I guess biological agents.
Well, we'll go back up to the computational view. How does he characterize that? So the computational view then is where we have finite sets of symbols, and those are encoding operations that can be executed on a universal Turing machine that exists in a small world. So that means that they're not extended outside of that world. It's just that finite set of symbols run. That's what the machine knows, is that finite set of symbols. Okay, and so then, this is something that they talk about in information theory as well, symbols and things like that. But, it's like, then they go on to say meaning and all this, or semantic. And, that's where you get maybe into a little bit of trouble. Because, but let's say for the sake of argument that we have maybe discrete units of something. And those discrete units in a computational view are finite. They sort of set up the small world of possibilities. Whereas if you go to like another type of system where you need, well, in the what we might call the real world, you need a greater number of symbols to actually make sense of it. I guess that would be the distinction there.
Mm. Yeah, I feel when I first read this, I kind of felt like he's sort of almost using a version of like the bitter lesson, but like from the biological point of view, in a sense, in a sense, saying, "Oh, biology would never, you know, it would be like not a good way for biology to develop to even try to do what he's interpreting as this symbolic algorithmic approach, because they can't operate at all in environments where there's so much almost false structure being put in. Let's see.
So this citation up here, Savage, 1954. What is that citation? He cites that quite a bit.
Let's see. Okay. Foundations of Statistics.
Oh, really?
In the old textbook.
Well, that's I don't know why you cite. Well, I mean, I imagine there's some reason why he's citing it. Maybe just the way statistics work. I'm surprised there's not anything more recent. But yeah, I don't know. I mean, yeah. I mean, when someone cites something a couple times, you want to know what it is that they're citing. So this is a Turing machine, but also how the worlds are defined. Yeah, okay. Well, that's fine.
Contrary to an algorithm, the most sensible and most rational course of action for organism simply does not follow a form of a logical inference, not even abductive inference at best. Explanation to the best explanation. Before they confer anything, living beings must first turn ill-defined problems into well-defined problems, transform large worlds into small, translate semantics into formalized syntax. And they must do it incessantly.
Incessantly.
And that, I think this is where Amanda mentioned, we had a little side discussion about, is this going to work? Yeah. This is somewhere later in the paper when we get there. While it's impossible to impose internal motivation on a system, external motivation on a system that mimics the aspect of internal motivation, so that's all wrong. true internal motivation cannot only arise from precariousness. If we wish to continue living without this drive, we do not. Whatever. This is sort of talking about like the mortality, like essentially saying the the uh, the incessant nature is sort of this: you have to survive, or you have to pursue some goal. This one, part of that. Let's see.
Can only arise from that? I don't
And it says in this paper, we shall argue the ability to realize relevance, to bring forth the world, is present in all organisms, from the simplest bacteria to the most sophisticated human beings. One of the key properties that sets apart living systems and their concrete physical limitations, which we will call machines. Interesting. Interesting part before.
So what was that again? We show that one of the key properties that sets living systems from algorithms and their concrete physical implementations. Oh,
That's
up
above.
Right, but like in this paper, we shall argue that the ability to realize relevance, all right, to bring forth a world, which, is present in all organisms, from the simplest bacteria to the most sophisticated human beings. So isn't that also like cognition is everywhere? It's just a different way of viewing cognition, or?
And that's what it took me quite a bit to figure out this breakdown, because this is where he's setting up his different factions, and I didn't quite get it, because he mentions like Maturana and Varela in two different camps, and he says contemporary approaches to natural agency and cognition take a wide range of stances between what they mean, blah blah blah. Some of these approaches consider cognition as a fundamental property of all living beings, including Maturana Varela, Thompson, okay. But some treat it as restricted to animals with sufficiently complex internal models of the world, or in its possession in nervous systems. And then, however, some see natural agency as a phenomenon that is clearly distinct from cognition. Rosenkaufmann, Moreno, Monsieur. So. Some consider the two to be the same. Maturana, Varela, Thompson, and Basukin Levin, particularly citing Levin down here, apparently. And he breaks it in these two camps called Agential Emergentism, who are the good guys, mostly, I think, and Computationalism were the bad guys. And I guess Thompson is okay, so he's citing Thompson's classification in this way, but saying Levin is sort of one of the big bads of the pan-computationalism. So I don't really know how he'd answer your question.
Well, I mean, if it's good and bad, but like everyone seems to be kind of in the same cantina.
But they're very much waging. They're framing their argument against the highly problematic pan-computationalists.
Right. But I mean, I guess the big distinction here is like it's either you're constructing a world from very little information, or you have a finite set of symbols that is driving that representation, or something like that. And I mean, that's the thing about the paper we read with Bongard and Levin is that they have to take that view because they're talking about humans and machines interacting. Machines don't have that capacity, but humans maybe have that capacity. So you can't, go beyond like, you can't just say, well, we're going to have human machine technology through systems that are kind of emergent and they'll just kind of develop their own thing. And I mean, that's kind of, you have like machines and humans interacting, that's going to happen because the machines don't have that capacity. On the other hand, I mean, if the machines did have that capacity, how would you build that? What would be the means? What would be the mechanism for that? I mean, if you have a generative system, you can generate new things that are not necessarily hard-coded into the system. So that's what generative means. I mean, it's within the bounds of sort of what the the symbols that the system has, I guess. But that's kind of the thing about a lot of systems like emergent systems like insect colonies or other types of collective behavioral systems, is that they have these sort of simple behaviors that they assemble in a collective, and then they produce higher level behaviors that are also, I mean, they're somewhat constrained by their environment and by the behaviors of the agents, but they can do things that look very much like strong emergence. So I mean, I don't know. I mean, it almost feels like he's taking he's trying to create a controversy here. I don't know.
And that's kind of like, yeah, we were trying to figure, we had the same sort of like, even when I was trying to, I highlighted these because it took me a few times to like get, what is he actually seeing these camps as? We kind of have 1 and 1A, and then 2, and then 3, which is sort of the same. And it's like, I understand he's coming from a very specific point of view, but also we can review that part of the paper here too. But yeah, it's sort of.
I mean, it looks like a lot of words, certainly. But,
as we shall see, this dialectic and hierarchical tangular process from the generative core of the phenomenon of natural agency. Okay. Yeah. In essence, a Darwinian adaptive evolutionary dynamic, our central claim, and what follows is this dialectical dynamic of relevance realization is a non-algorithmic process.
okay.
Therefore, these things are not computational.
What is it? Wait a minute. It is, in essence, a Darwinian adaptive evolutionary dynamic, which could be computational. You could build like a evolutionary computational program and build a adaptive evolutionary dynamic system, or you could do this with mathematical modeling. But our central claim in what follows is that this dialectic dynamic of relevance realization, which I'm kind of baffled by what that means. It's like I don't know, is not an algorithmic process. Okay, well, so I mean, I guess dialectic means you're interacting with something else. There's a dynamics there. There are two systems with the same set of symbols. They're kind of interacting. They're putting together some solution. Maybe that's not known to either of them pre interaction. That's not an algorithmic process. Okay. Therefore, natural agency, cognition, and consciousness are at their very core non-computational. I mean, that's a pretty strong claim to make. I guess you have to prove the counter. So, I mean, or to actually say that it's a computational process. In the first place, I don't even know if that's what the first camp is saying, the computational camp.
Yeah.
I mean, they kind of are saying that agency and cognition are computational, but like it's kind of like you're just using like this point. You say, well, I found something here, this exception, or maybe like a way of solving this, and then they're wrong. That's just the way it is.
I've kind of been interpreting a little bit of like this bit about radically context-dependent generative dialect, and this footnote. I kind of interpret it as like saying computation is too, like there, at some point here, where did it say? Okay, yeah, let me go back up here. Sorry. Like I'll go to this first. It's sort of like. I'll just read this. The dialectic is a term heavily burdened with different, often metaphysical, even political interpretations. Here we define it simply to mean dynamic of two or more interrelated processes whose interactions do not merely feedback on each other.
Okay.
They kind of label cybernetics as like the wrong way to view some things below, but are reciprocally constituting. In other words, they process a mutual code construction. So computation and cybernetical things are not.
What is it?
Not.
But why can't you build something, or why can't you have mutual co-construction through cybernetics?
Yeah.
I mean, you could build like a cybernetic system to do that, I suppose, or you could build like, the thing I found with doing this paper, which by the way, I did get an email from our editor, and he loved it, so that's good. The paper we're doing, so good. But the thing I found through this paper is a lot of these terms are kind of very loose. So it's like, cybernetics, they didn't really specify a lot of the mechanisms. So it's like, they specify this worldview and specify kind of the parts. And they say, well, you could use like, Shannon information or something. But, they don't specify much more than like a simple positive feedback loop, or maybe like a closed loop feedback. There's so much more there that could be like, they could be cybernetic. I mean, I don't know. It's just, they kind of put out this basic framework, and then you say, well, anything they didn't use in their writings is not going to cut it.
Like, I think this is, I don't know. This bit about here, excuse me, when they're doing computationalism is saying it formulates agential and cognitive phenomena in terms of often complicated, nonlinear, and heavily feedback driven, but an input-output information processing. And so, you can hear the sass or the snark a little bit, but in this framework, goal directness, sometimes unironically called machine wanting, tends to be explained by some kind of cybernetic homeostatic regulation. So it's framing it as like mechanistically simple and potentially irrelevant to how things work. And it's like,
Well, I mean, nonlinear, heavily feedback driven, complicated sounds like maybe it just fits the bill. I don't know, but I don't, I have to see like a comparison between them, to see what the. I guess I'm. I don't know.
And Morgan mentioned that the Beluska 11 person. Beluska might have been from the pushing boundaries biology conference that we mentioned some months ago.
Oh, what about
that? Was Amanda, but yeah.
What about that?
This is referenced, yeah.
It was just a reference to the conference here. So I mean, we were kind of wading through this, and it's kind of maybe not the most interesting, like the framing is to further the point they're trying to make, but we kind of waded through this a bit, and next time we wanted to get into like, okay, so what do they actually say, like what's the positive theory he's asserting, and does he talk more about, like, Amanda wanted to find out where he says something about simple versus complex machine arguments, like what is simple or what is more complex, how do you define that, and how does it relate to this? So I'm trying to think if there's anything else interesting that happened sort of in the first part of it. We jumped around, but basically got this setup. I guess I'll mention what the paper is supposed to have. Section 2 is this sort of his litany of problems with the different, his different camps. And then he goes into the process of relevance realization, outlining its functional role in cognition. Okay. And then he goes into the notion of biological organization, showing how it emerged as a novel kind of organization of matter at the origin of life, demonstrating blah blah, basic autonomy, natural agency through the organism's ability to set its own intrinsic goals. The pursuit of these goals requires anticipation of consequences, and how this happens is discussed in section 5. Okay, and in six it's about the dialectic interplay, which is not computation, between the organism's goals, actions, and affordances. And then the core of the argument is we bring this model to bear on the process of relevance realization itself and show how this process cannot be captured completely by any kind of algorithm. In 7, the insights are showing how the evolution of cognition in organisms with the nervous system and perhaps also conscience can be explained by adaptations to realizing relevance. Okay. And then a bit more in terms of problem solving. We argue a basic ecological notion of rational behavior is common to all living beings. In other words, organisms that make sense of the world the way that makes sense to them. So that's basically what we talked about in essentially the same amount of time.
Yeah.
We're now caught up, and we have our questions about the paper and what is he actually going to say.
Okay.
Yeah.
Yeah. So I mean, I guess that's a pretty interesting way to approach the problem. I mean, the idea that an algorithm is sort of like this finite, basically a finite state machine, if you're familiar with those. And that's basically what you have, and then you have to have new categories sometimes for things, and that doesn't come easily in a finite state machine. Although you could add in states, we have all sorts of computational tools for that. We could have things that aren't really states at all; it becomes states. So that's something else that we can consider. And then we have things that I guess there's this again. People are leaning on meaning. When I hear that, I always think like, I think that like they're just trying to use words to kind of weasel out of something because it's always like wasn't fully explained. Well, okay, but that's, I mean, I guess the whole point of computation in a sense is that it's, I mean, at least the way humans have explored it is that it's a good enough model for nature, and so it is maybe with an organism that they just need good enough models. But they don't need to fully characterize all of their experience or all the world.
Mm-hmm.
They just need to characterize enough to survive. And, that's what we do with computational models. We don't try to model everything in excruciating detail. We just build a model that's like a heuristic. So I could build a model of, say, like a complex system like a city. It could be pretty compact. It could have like maybe 10 states where you have transitions between the states. And for like 90% of the cases, it would work. We think about scientific theories as sort of like this, very, very simple enterprise where we try to simplify things as much as possible. We use Occam's razor to describe things. And in fact, the whole point of a scientific theory is to be as sort of efficient as possible with our sort of our words and our concepts and our terms and our mechanisms. So we don't want to like just say, well, there's this collection of things that maybe happen once. We'll have to incorporate them into the theory. Usually we don't worry about that too much. We just come up with a theory that's the most parsimonious. And so does that work in terms of building an organism's experience of the world? I don't know. But that's something that we as organisms do in terms of, we can build models understanding the world like that. But yeah. So yeah, I don't know. I mean, I don't know. I would like to see some more like technical. That always seems to give me a little bit more it always seems to make the impression on me as like the technical argument. I mean, not like words, but like like a model and show like the differences. So you have some models actually here, I guess.
Amanda took out some of the pictures, even though she was like, they're fun, but maybe not the most informative. I think the first one was Simon's scissors, which is I don't really know if that's a thing somewhere else, but problem-solving toolbox, experience arena, physiology, morphology. I guess I don't know. I don't really know what.
Yeah. So you have experience in problem solving, and you kind of cut the world like that in between the scissors.
It looks like this is part of the bounded rationality discussion, as illustrated by the metaphor here.
Okay, this is Simon. Okay. So this is someone like the bounded rationality idea characterized in a cartoon, which is great. Did he draw these cartoons? I don't know. If he did, it's wonderful. I don't know.
This other one looked pretty nice. This one evolves a
There we
bit, I
go.
think. The dialectic understanding. Where was this introduced? Let's go to figure 2. Okay. This is Rosin's central insight, and we're still. Is this part? We're in part 4.
Okay.
Okay. And then he's saying Rosin's central insight into his MR systems.
Yeah. Yeah, those are the
Organization closure. Cybernetic feedback. More than mere cybernetic feedback,
Right.
more than a raven can hunt for in the night. Yeah. Immanent causation, more than cybernetic feedback. Okay.
Yeah, I think like one of the problems with cybernetic feedback too that I'm learning from this paper is that like I think the cyberneticists really botched up the idea of feedback in some ways. Like that, they have like this. They kind of define feedback and what it is, but like, um, I don't know. I mean, maybe it isn't like it isn't the best possible definition they could have given it. I don't know, especially like in the ever good regulator theorem. It seems like there are a lot of like things that are lacking there. So I mean, I wouldn't say that like that we have to get rid of cybernetic feedback, but I think like they didn't refine the definition quite enough, especially with respect to like real world systems to, have a something that we can defend.
It's tough in the sense of like feedback kind of in thinking about like the history of cybernetics and everything, feedback like the way observer changed was interesting. But I feel like feedback maybe use the word botched. I wanna I think a little bit like if we kind of got out of hand, like it just became like I keep thinking of the extreme, the extreme silly end of the spectrum of that book. I don't know if I don't think I got it, but it was sort of like the psycho cybernetic or some kind of solution where like you get to use these cybernetic principles in this very outlandish way, talking about feedback in a very outlandish way, and that's obviously like not academic
Yeah.
work. But then in this sort of academic sense of what feedback is, it sort of became it'd be very interesting to think about that in terms of like the reimagining
Yeah.
cybernetics.
Yeah, I mean, I guess my problem with feedback is that it's very, it's almost self-referential in and of itself. Like we say, what causes this thing? Feedback. It's feedback. Feedback will create things that are, nonlinear, or feedback can also create things that are feedback. And it's like you have that circular causation. You have to be careful with, how you conceptualize it. And they were not. So it was this kind of general, it was a very general set of terms or a very general set of predictions that they made from it. So it's and of course if you have different systems, the feedback aspect is going to be very different. Like
Mhm.
if I have feedback in a biological system versus feedback in a machine, and better yet, if I'm coupling the two, what does that look like? Is that the same thing? Are they going to be compatible in terms of the signal? What is the signal? Et cetera, et cetera. So yeah, it's really tough.
Yeah, it's oh, I thought Morgan was it wasn't Morgan. Sorry, as a background noise. Um, uh, it's in this part of the discussion, I've I've never really been sure as much as it's like cybernetics sort of tries to talk about the observer and the role of the observer, and even much around this sort of distinguishing cognitive domain stuff as a separate observer only space kind of a deal. Microphone. it's sort of like there's a little bit of in my critical hat along these lines. It's a bit like the even though Maturana, I guess I'm sort of bridging from that, but yes, the purpose. I guess I don't know how to say this, but sort of a little funny business about what is the purpose and what is like there's something is and is it just enough to say it's the observer in its own cognitive domain, but something is clear like the role of feedback and the ascribing it is of this purpose feels like it just like where's the assignment of that actually come from and even in like talking about it or no less trying to diagnostically sort out the system itself like here's an observed potential purpose I guess that's what Mark Toronto would say but I don't know
Yeah, I mean, like this. So this image figure two is interesting because it basically, you remember we were talking about allostasis last time, and one of the views of allostasis, yeah, is that these are great conical shells here, um, of a gastropod. But we talked about allostasis and how it's sort of like a set of trade-offs or balances with respect to like energetics and things like that. So that's basically this is I guess describing Rosen's immanent causation, where you have that sort of recursive aspect. So you have the cellular milieu, which is everything in the cell, metabolism, etc. You then you're trying to refine that maybe through some sort of process, and there's this balance between survival organismal or organizational continuity. So basically, to keep things in say homeostasis, you need to do some things, but that's of course because everything is changing all the time. You also need to make sure that you survive, and so this kind of twists you into a sort of a refinement of that system. I guess that's what they're trying to
right
say here. Yeah, but it's this balance of like what are the goals of or what I wouldn't say goals, but what are the imperatives of continuity, what are the imperatives of survival, and it's just kind of trying to maintain a balance between those.
it it makes sense and I haven't really looked at I haven't really studied this one yet even though I had some on my screen certain like gravity or attractor points and okay sure let me see it's interesting to think about this also in terms of like the diagram and I can't pull it up but the Josh the Bongard paper and their diagrams too anyway yeah
And it's worth noting that of course in computational systems we also have recursion, and we can do I mean it's not a balance, it's more like we just self-reference things, and we can do things like build loops or tables or something, and this is like in computers, but we can have like I don't want to call them data structures, but we can have recursion in computational systems, and oftentimes
mm,
we do in like in a computational system where we go between states and we reinforce states and things like that. So I mean, I don't know if you could do this maybe in a computational system. It's just the choice of saying that it's driven by this, active construction process. So I mean, like what you see here as a diagram could be done by emergent causation, or it could be done by computation, depending on how I mean, it doesn't preclude it from being one or the other, I guess.
mm. Oh, missed one here okay we have a I guess a bonus well 10 minutes left before the top of the hour. I'm a little curious about what the editor said, but if you want to mention anything else about this, we have some things, we picked some things to talk about for next time, which I already mentioned. So, anything you want to specifically highlight on next time, or that you want to continue next time, or just kind of go through it?
We can go through it some more. I mean, Morgan, do you have a preference for what we want to do, or?
For this particular meeting, for the Cybernetics reading?
Yeah, for Cybernetics.
Well, I would love to continue reading the 11 papers we haven't read yet.
Yeah.
What?
Yeah, and I want to get into well, I'm not sure whether it's the ones that we've already posted or whether some of the discussion that he had today, there might be a good reference, because he anyway, I'm going to check what his student has published that was on the
Video
broadcast today.
Yeah.
Okay.
The only other thing I mentioned at the very start, Amanda talked a little bit. We can ask about this next time about her interest in memory, and like we've done some things with the physical memory stuff, with a bunch of different things. We had some nice. There was something said about there that I think I'll remember later, but Amanda mentions looking like for like the cognition futures kind of project stuff, just interested in memory, or maybe that was more the cybernetics reading group, not the cognition futures. I don't remember which it was at the time, but just interested in memory stuff. So yeah.
If I could bring up one other thing, just so that you can make a note of it and
Sure.
remind me to follow up. There was a talk by a Caltech professor, and I'll go through. It's certainly in Slack. That was talking. It was kind of like modern control theory, and what I forget exactly, but it was talking about how layering, again, some very particular definition of this, but layering was important for the for added complexity in control theory, and it sounded like a really kind of somewhat focused, a computationally focused paper that touched on good kind of control theory, cybernetics, domain.
Okay.
Yeah.
I'll make a note of it here.
And
yeah, quickly in Slack, but I'll look later.
I'll try and find that too, for sure.
Okay. I guess we'll leave the paper here for today for this and pick it up next time. We basically are all caught up. We're all in the same spot now, basically.
Yeah.
Kind of ready to go on beyond the polemics of the framework of what his camps are, and getting to what he wants to assert in the paper as the way to be. Anything else? I know you mentioned the other. I think were you talking about the Royal Society paper or the other paper? Or I don't remember which one.
Royal Society paper, I assume. I didn't know there was another paper.
Yeah, I don't know if it was for like past stuff.
Oh no, this is the one we just submitted. Adam
Great.
Saffron is the editor on that, so
That's cool.
yeah.
Okay.
You know, it'd be fun is if we could spend some time thinking about what emergence actually is with respect to computation. And I don't know, maybe that isn't something that everyone wants to. We don't want to really do a strong deep dive into that, but if we could get because you see emergence thrown around so much, it just seems like people use it in lieu of magic. And so I'd like to, you should really, and I think especially here, I mean, it gets defined in contrast to computation, but there are there's a lot of the stuff that's written on emergence, this is a very philosophical point of view. So there are other points of view on it as well. And so it'd be nice to know like kind of what the range of viewpoints are on emergence, because it seems like
And
we run
yeah,
into
and
this.
you mean that outside of like not just in the paper, but like what are people trying to do? Like
Yeah, so like physicists have like their conception of emergence, and philosophers have their conception of emergence, especially philosophers of mind. And then there are other people talking about emergence, different things, isolated systems, whatever. And it's like, it gets quite messy. And people can throw, it's like in cybernetics, where people will throw terms around.
yes.
Yeah, and so, what would it be? Like, what would we have? Like, if we had a system that had a lot of feedback and it's producing something that's emergent versus something that's not emergent. So in the A-Life community, they did try this a long time ago. I remember there's some early papers on strong versus weak emergence, and like defining emergence as being either like strong, where it's an active process, or just kind of weak, where it's just kind of interactions that lead to things that you can observe. Strong being maybe like its own sort of hierarchical level of complexity, where like if you think about it, a social insect community, they actively build that from their own interactions, but then that is its own thing with its own properties, versus maybe like something like weak emergence, which is just something that results, like maybe like a pattern in a, if you put some chemicals in a medium and they form patterns, is that is that used as a structure in and of itself? And so those are the definitions of. And so like thinking about those and thinking about other ways that people have kind of parsed out emergence would be really interesting.
That okay, Morgan.
Oh, I was just gonna say, yeah, I'd love to have that discussion, and it would perhaps help to talk about, or our when Levin talks about multi-scale agency, is that synonymous
Yeah, right.
with emergence? And I think that this has something to do with layering, in that 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 what this control theory, computational control theory guy was essentially talking about was something like multi-scale control theory.
Yeah.
And as you move from scale to scale.
Yeah, and like that's Levin's thing is like the top down and position from the lower stuff.
Yeah, I think definitely. I've been definitely just keeping all those terms straight and what people are really getting at.
Yeah, all those terms straight, and to perhaps how that relates to this kind of redefinition of machines and self healing.
Yeah. Self processes. Like
he really emphasizes this that this kind of definitional issues with regeneration and the need to think about things differently. And anyway.
Yeah,
it would be a great topic.
Yeah, like self-organization, self-healing, Yeah, I mean, self-organization is another kind of catchphrase that people don't use as much anymore, but they used to use it all the time, and it was like, what do you mean? Well, organizing on its own basis. Well, what is it? You have to start somewhere, but also you don't. And so,
again, this is anecdotal, right? Like, I should do more of kind of a proper search review kind of on this, but like I'm seeing more references to self-organizing maps in the machine learning literature, which I think is a funny, like I haven't seen those in like
30 years,
20 plus years.
Yeah.
And it's just like, oh, people are, like somehow, for some reason, Cahonen is coming back.
Right.
And that would be, So anyway.
It'd be really funny. It'd be really funny and not something I want to do. But like, if I could just, you know, snap my fingers and have her do it, we sort of like almost like measuring in a more than just like a classic like Google history search, or like even more than the bibliometric, because I don't like actually knowing
Yeah.
some of the details about how like the trend, just the trendiness of
Yeah.
certain concepts, you know.
Yeah,
Oh,
yeah,
yeah.
yeah. Well, I mean, it's so much like,
In a
I mean,
like
it's really what the computational story lab does, right, with
Right.
Twitter. Or, well, I guess, you know, I don't know if they give it up on Twitter. But who's the guy there, Bradley?
Can't remember, but I know what you're talking about.
You know, this is the sad thing about, you know, Twitter not being a thing. Like he was one of the people who I actually commented on his stuff.
Oh yeah, yeah.
You know, he's very low key though. Anyway, but that's kind of what they're doing. It's like online, you know, like you know, dashboard analytics for Twitter.
Right.
And you know, but not just trying to catch, you know, not trying to catch the usual, you know, the company interested stats or, you know, trends, but trying to track, yeah, various kind of social science issues.
Yeah.
And it absolutely relates to, you know, again, like how I've seen network science and other related kind of, yeah, graph neural net causal analysis of again, social media for making kind of like big, you know, national security, like forecasting, you know, like monitoring Twitter to see when a particular country is going to have a revolution or something like that.
Yeah.
You know,
When that,
yeah.
When that Twitter API went away, like a whole subfield of network science collapsed.
Yeah. So, you know, like, anyway, yeah, just seeing some, you know, from some people that are close to Elon Musk, just their comments about like wanting to shut that down,
yeah,
are just really, you know, just done with no good, you know, no moral sense.
yeah.
Anyway, it's such a loss,
Yeah.
But I've been thinking about it though, Jesse, in terms of a project that we were thinking about restarting. You know, remember the what was that Latin American students at MIT, um, you know, website, kind of like connections between papers. What was that project?
Oh, state of the art AI.
Oh,
Yeah. Anyway, there's we're some changes going on at NeurotechX, and thinking about revisiting a kind of a review paper, making a review paper that Yannick had done on BCI into kind of an ongoing, you know, like dashboard of you know, yeah, papers as they come being added to this kind of, you know, a kind of annual review.
Yeah.
You know, just have it build up, have it be reviewed, you know, and collecting
Okay.
a small slice, but with that, you know, that same kind of.
I would be happy to share my in-depth knowledge of why or why not things went the way they did with that particular project.
Yeah.
Which would be a benefit.
but certainly be great. It would be interesting, especially if you think that there's people who'd be, interested in kind of discussing, technically how best to do that kind of thing. And anyway, we should talk about that though, because there are some things going on at NeuroTechX and one of the people involved is actually at MIT. So it would be good to talk.
Yeah, because there's I want to do more with NeuroTechX in general, and there's like Boston version of that here that I've been dancing around. I'll briefly mention I got accepted to some really cool AI in some of the like AI business events, which are kind of different. But I'm going to be really busy in the next few weeks, month or whatever, hopefully. And I want to. I keep asking my friend who's running a bunch of like the lists and updates to keep track of those events. Like, okay, what about like sort of health tech? What about neurotech stuff? So I'm interested. I want to do more. There's stuff in that space, and we can talk more about it later. I know we're going over time here and all this stuff. So,
okay. Let's talk.
Yeah. Cool. And then yes, I do want to definitely highlight like Bradley's thing about emergence and computation. I think that would be a really nice cross-cutting thing for the lab in general that we can look at. Yeah. So that's like it makes me think honestly. I thought like, oh, that's like FQXI kind of question, like really deep, like what is this? Well, not really. A little bit more domain agnostic, but cross-cutting in our interesting ways. Anyway, I have to go too. But this is very fun, and the timing was a little weird for everybody today, but we made it work, and a lot of good things happened, and I'm sure we'll have one more to say next time.
Yeah, great. Thanks for meeting. Bye.
Take care,
everybody. Bye-bye.